Access modifiers specifies the scope of the class attributes. So from where they will be visible, from there where they should not be visible. So there are three types of access modifiers: private, public and protected. So if we specify the attribute of a class as private, so it can be visible within the class. So if we specify the access modifier as public, the attributes of a class can be accessed from anywhere. It can be outside the package also. If it is protected access modifier, then they can be accessed within the package or in one of its subclasses. So if we don't specify any one of these access modifiers, by default it will be visible at the package level. So at the package level, for all its classes, it will be visible. So if you move to different package, your class, it cannot be accessed. The protected variables cannot be accessed. So I will be creating a variable named private. So within the class, you can access all these private, public, protected and default attributes. So I will create one more class. So I will create an instance of access modifiers test. So here see, you can access default, protected and public. You cannot access the private attributes from the other class. You can access only inside the class. Similarly, you can define the access modifiers for the member functions of a class also. So here I have defined the public access specifier for this member function so that it can be accessed from anywhere. So if I don't want to access it, I can from outside I can say it as private. If you don't want to expose that behavior outside the class. So I will create new package. So the class itself is not accessible outside the package. So if you wanted to access the class, so as you moved out of the current package, you have to import this class into the current class. So there is a keyword called import for importing the other classes. So this class is from COM training. So now we have imported this class so that it is able to see this class. So using import, you have imported the specific class. If you wanted to import all the classes in the package, you can specify the star. So now if you see here outside the package, you can access only public variable. You cannot access protected, default or the private. So when you extend it, so in the current object you can access the protected as well as public. Because it is outside the package, you cannot access the default attributes. So this is how the access modifiers will work. So based on the requirement, we will specify the access modifiers, which functions or which member functions that needs to be exposed outside or which we wanted to keep as private for the security. So we can define. So for accessing the private members, you can provide some member functions. Suppose for accessing so here you can control based on the permissions. Here you can control the access to the private members. If it is permitted, then you can return the value, otherwise you can throw back the error. So access members specifiers you can specify at class level also, attribute level and member function level. In the abstract classes, we are providing the some attributes and default implementations. If any of the behavior that has to be implemented, so only that behavior we will make abstract using abstract classes. We have already discussed the abstract classes. So interface is also similar to abstract class, but here you will not have any default implementations. So this is also a kind of class. It will be defined with keyword interface. An interface will have the behavior that some class needs to implement. Suppose if you wanted to create the interface for car, so what is the expectation from the car? So we wanted to drive, we wanted to apply brakes, we wanted to give the indicator signals, we wanted to use wipers. So these are the behaviors expected from the car. There might be so many features. So you can put all those features as a part of interface. So all the cars one can implement this interface. So this is a kind of standard. So if I wanted to call it as a car, I wanted to have this behavior. So if this behavior is not there, I will not call it as a car. Similarly, you can define a type using interface. So whoever is implemented this interface, we will call that a class is satisfying this behavior. All the methods in the interface are abstract by default. So whichever is the class that is implementing this interface has to provide the implementation for all these methods that are defined in the interface. So interfaces cannot be extended like classes, it will be implemented. So implements keyword is used for implementing the interface. So interface, you will not have any attributes like class. So it will have only member functions, and you can define some special constants. So let us create an interface. Sorry. So like Java classes, so the class file will be generated for interface also. So in the interface you cannot define attributes like class. So you can define only public static variables. It must be static also. Similarly, you can define some member functions. So you can define any member functions as you want. So you can define a class so that can implement this interface. When I say implement this interface, it has to implement all the behavior or member functions that are defined in the interface. So here you can provide the implementation for those methods. Similarly, different cars can be created, but all the cars of type this interface car. So if I add any new behavior to the interface, I have to implement it here. So you cannot provide any duplicate implementation in the car, default implementation. Suppose if we are using the abstract class, we can provide the default implementation and we can add the behavior. So I will implement one more class. So if you add the behavior to the class, you must add for all the classes that implements the interface. So if you use abstract class, so I have defined an abstract class and I have defined an same interface. So what is the difference between the abstract class and the interface? So in the abstract class, you can provide the default behavior. So the subclasses can override this. Suppose if I add one more behavior to the car, new feature, so I have to change all the cars that have already implemented for the new feature. But if I add new feature in the abstract class, I need not change all the implemented cars. So I can provide with the default implementation. So if any of the car that wants to implement the new behavior that was added in the abstract class, they can override the implementation in the subclass. So interface and abstract class both are same. So in the interface you will not provide any implementation. You will define the behavior. So you cannot create any instances for the interface. Similarly, you cannot create any instances for the abstract class also. So in the interface you will not have any private or protected attributes, but in the abstract class you can define it as a class with the attributes and member functions with default behavior. Here I have an abstract class that implements the interface car, but I did not implement any methods from this interface, but it is not showing me any error because I have defined this class as abstract. So the subclasses who will extend this abstract class, they will implement the methods in the interface. If you specify the class as abstract, you need not implement the methods in the interface. So once you define the interface type, you can create a attribute of type that interface, and you can assign the implementation. So when you define a class or interface, you are defining a type. So you can create an instance of interface, but you cannot instantiate, you cannot define the constructors in the interfaces like we can define in the classes. So we cannot define the constructors, but we can assign the implementation classes objects to this interface type. So when you are creating an objects in the program using new operator, so it will allocate the memory for those objects in the Java memory heap space. So these objects are accumulating when you are creating those objects. So programs might be running throughout the days. So our programs examples will not run those many days, but when you implement the programs in the real world, so they will be running throughout the days. So in that case, the memory is crucial. So there will be so many objects created as a part of program execution. So if we don't clean up those objects from the memory, so then we might get memory out of errors. So Java has a garbage collection mechanism. So it will run in the background at some periodically or some at random intervals of time, and it will clear all the objects that are not having any reference. So it will deallocate the memory for all those objects. It will frees up the space, as well as it will defragment the Java heap memory that was allocated for the Java program. So it will run in the background, you need not do anything. So it's a background process. So Java will execute clearing the objects. so that are not having any references in the program. So if you want, you can manually invoke the garbage collector using system.gc method. So there is a system class in the java.lang package, so which has some utility behavior like writing to console, reading from console, and this kind of garbage collection invocation. So you can use this system.gc for invoking the garbage collector on demand. But nobody will do this because Java will do it automatically whenever the memory is increases. So the finalize method. So when the object is getting cleaned, so the finalize method gets invoked on top of that object. So if you wanted to write any behavior before the object is getting cleaned up from the Java heap memory, you can write the implementation of, you can write the behavior in the finalize method. So object class is the super class. So there is a class. So java.lang.object is the super class for all the classes in Java. That is by default, object class is the super class. Even you need not have any extents or anything. So by default, Java will make this object class as the super class. So that class has some methods. One of them is finalize. So the object class has clone method equals finalize hash code toString. So you can override the finalize method of the object class. So you can write your implementation over here. So this will be invoked automatically by Java garbage collector while cleaning the objects that from the memory.